Hello students, in this video I will discuss astronomical telescope, the ray diagram and its angular magnification. Telescope. What is a telescope? Telescope is an optical instrument used to see distant objects. দূৰৰ বস্তু চাবৰ কাৰণে টেলিস্কোপ ব্যৱহাৰ কৰা হয়. Now broadly there are two types of telescope. One is called refracting telescope. The other one is called reflecting telescope. In refracting telescope, lenses are used, while in reflecting telescope, mirrors are used. There are many types of refracting telescope, but in your syllabus we have astronomical telescope. This telescope is used to see heavenly objects. Now what is heavenly objects? Objects, that is planets, stars, comets, etc. The other type of refracting telescope is terrestrial telescope, which is used earthly objects far away but on the earth. There are different types of reflecting telescope also, but in your syllabus you have Cassegrain telescope. There is another telescope called Newtonian telescope, that is also reflecting telescope. Now let us learn about astronomical telescope. In astronomical telescope there are two convex lenses. One is called objective, which is near to the object and bigger in size. The other convex lens is called eyepiece, which is near to the eye and smaller in size. For objective, focal length is large. FO is the focal length, which is large. For eyepiece, FE is the focal length, which is small. Since the object is far away, so the incident rays are parallel to themselves. But remember, they may not be parallel to the principal axis. Here I have shown two incident rays parallel to themselves but not parallel to the principal axis. The incident ray, which is passing through this optical center, moves straight without any deviation. But the incident ray here suffers refraction and produces image at the focal plane. Here this is the refracted ray. Two refracted rays meet at this point, so this is the image. This point is called the focus of the objective. We call it FO. Thus A1 B1 is the image formed by the objective at the focal plane. Here it is important to mention that if the incident ray is parallel to the principal axis, then after refraction it meets at focus. This point is called the focus. But when incident rays are parallel to themselves but not parallel to the principal axis, the refracted rays meet at this point. This is the focus. This plane is called the focal plane. So image is not exactly at the focus but on the focal plane. Here the image is exactly at the focus. Here the image is on the focal plane. In astronomical telescope, objective produces image on the focal plane. Here A1 B1 is the image formed on the focal plane of the objective. Since the image forms at the focus, so this distance is known as the focal length, denoted by FO. For eyepiece, for this lens, A1 B1 will now act as an object. The distances between the two lenses are adjusted in such a way so that this A1 B1 lies exactly at the focus of this eyepiece FE. So this point is the focus of the eyepiece also. This is the focus of the objective as well as focus of the eyepiece. Then the distance between this A1 B1 and the optical center E of the eyepiece is FE, which is focal length. Focus, optical center, so this distance is focal length. We know that when an object is placed at the focus of a convex lens, image forms at infinity. One ray will pass through the optical center, moves undeviated. Another ray is a parallel ray. After refraction, the parallel ray passes through the focus. So these refracted rays are parallel. So when you produce in the backward, they are also parallel. So image will form at infinity, which is virtual and magnified. So the same thing will happen here. One ray passes through the optical center and moves without any change, no deviation, straight. Second ray is a parallel ray, parallel to the principal axis. So after refraction, it will pass through the focus. These refracted rays are parallel rays, so they will never meet. These produced rays are also parallel, so they will never meet. We imagine they meet at infinity, so final image forms at infinity. The object is at infinity, the final image is also at infinity. This is the ray diagram of astronomical telescope when the final image is at infinity. Now we will calculate angular magnification or magnifying power when the final image at infinity. It is defined as a ratio between the angle made by the image at I when at infinity, and in the denominator, angle made by the object at I when at infinity. Thus, angular magnification may be defined as the ratio between the angle made by the image and object at I when at infinity. In this diagram, image is at infinity and the angle made by the image at I or eyepiece is beta. Similarly, object is at infinity and the angle made by the object at I, this is alpha. Angle at O and angle at E will be same since the incident rays are parallel. Because for parallel rays, these angles are equal. This is known as corresponding angle. Okay, here you can think there is an objective, here you can think there is an eyepiece. So angle at objective and angle at eyepiece is same. Now this angle and this angle are equal, so it is alpha. This is also alpha because they are vertically opposite angle. Thus the angle made by the image is beta and angle made by the object is alpha. So the angular magnification is beta by alpha. Since alpha beta are very small, therefore 10 beta can be written as beta and 10 alpha can be written as alpha. We'll write here. Now we'll substitute the value of 10 beta and 10 alpha from the figure. From the triangle A1 B1E, A1 B1E, 10 beta is perpendicular by base, that is A1 B1 by B1E. From triangle A1 B1O, we can find 10 alpha, which is A1 B1 by OB1, perpendicular by base. So A1 B1 by OB1. Now we'll substitute 10 beta and 10 alpha in the expression. 10 beta is A1 B1 by B1E divided by alpha, so we have written into, so it will be reciprocal, so OB1 by AB1, then A1 B1 will cancel each other. Thus we have M equals to OB1 by B1E. From figure, OB1 is FO and B1E, this is FE. We can write minus FE using sign convention. OB1 is FO, B1E is minus FE. Substitute here. So FO minus FE. So this is the expression for angular magnification of a simple astronomical telescope. The distance between the two lenses, objective and eyepiece, is L, known as length of the telescope. L is the length of the telescope, and this is FO plus FE. What is L? FO plus FE. Thus L equals to FO plus FE and M equals to minus FO by FE. Thank you very much.